Alright, so this is how my enemy AI looked a year ago. It's pretty straightforward, just NPCs patrolling a preset path, but this is how it looks now. And on the surface, it may not look like much, but every zombie in this version of the project is making their own decisions for the best way to find food. Some are searching alone, some are choosing to go to areas that frequently have food, and others are deciding to stay in a group, and some of them will even attack each other out of desperation. So they're all able to do this because of goal-oriented action planning, or GOAP for short. And needless to say, I think this is really cool, and I'm like really happy with the result. But there's something deeper here that needs to be discussed. See, it almost feels like GOAP works too well, like it's too good to be true. Like with my example, I'm 90% sure my implementation is broken, like I didn't implement it correctly, which I'll get into later. But it's crazy how even with an incorrect implementation, the result is still this good. Plus, it still performs well, at least in this use case. And you know, maybe it's just my algorithm, but a quick Google search of GOAP gives nothing but praise and tutorials. So there's got to be some downsides here, right? I know I didn't just stumble into the one thing the internet isn't divided on, because if there weren't any downsides, everyone would just use GOAP all the time, right? So I decided to dig a little deeper, and I did find a few things that I think are important to know before designing an entire system around GOAP. What's good, everyone? I go by Shinobi, and this channel exists to show what I'm learning and get feedback from you, because I'm just a guy that's learning this in his free time. And you know, we wouldn't be here without your feedback from this video I did almost a year ago. In that video, you pointed out a few misunderstandings I had about AI, and now it feels like the time to make those corrections, because understanding those small things made a huge difference in how I implemented GOAP. So back in that video, I referred to state trees and behavior trees as AI themselves, and I don't think they are, at least not in the way that I'm using them. They're a means to implement the AI I designed. I know that seems like a small difference, but it mattered because it helped me understand that learning these tools wasn't going to make me suddenly be good at enemy design. There's a lot more that goes into it than that. Probably never would have made that mistake if I had enrolled with today's sponsor, Southern New Hampshire University. So I definitely can recall a time when I felt stuck at a job I didn't like. For me, it was my first job out of college, and I wasted 7 years there, really just making a bunch of excuses to not quit and find work that would be more fulfilling for me. But the beautiful thing about my computer science degree was that it offered a ton of flexibility and gave me the freedom to pursue a new job, as well as dive into game development here. And that's what I love about the game development degree program today's sponsor, Southern New Hampshire University, provides. SNHU offers multiple fully accredited degrees in game development, one tailored towards game art and the other towards game programming. SNHU makes your success their mission, so they offer these courses online with multiple start dates to be as flexible as possible. Since they're online, you can attend class whenever and wherever it's convenient for you. They also offer loads of other resources like academic advisors and career services as you need them. Now, from my personal experience, I know how difficult it can be to find reliable information while learning game development on YouTube, but SNHU hires staff with real-world experience, so their specially trained instructors are capable of helping you develop the skills you'll need for success. I'm gonna be honest with you here. The real reason why I'm rocking with SNHU now is because they offer solutions to problems anyone considering higher education is facing now. The first of which is student loan debt. We all know how wild it is, especially if you're in my generation, but SNHU prioritizes affordability for their students by having one of the lowest priced online tuition rates in the nation, so you can achieve your dreams at a price you can afford. Second is the job situation in the gaming industry. We've all seen the layoffs that have been happening, but gaming degrees that SNHU offers will help prepare you because they'll teach you skills that are valuable in multiple industries. Through their program, you can learn to code in C#, Java, and C++. They also offer classes in digital graphic design and 3D art and design. So don't be like I was. Don't spend any more time at a career you hate, and start taking steps to get where you want to be by going to snhu.edu/shinobi for more information, or just hit the link in the description. All right, let's get back to it. So let's start by getting on the same page and defining GOAP. Goal-oriented action planning is a flexible AI technique that enables the developer to build a set of actions and objectives and allows the NPC, or agent, itself to determine what the best objective is and how to accomplish said objective. It's basically a framework for creating an AI system that makes gameplay feel more immersive. And the reason why it blew up so much was because instead of the predictable behavior patterns of NPCs at the time, GOAP gave NPCs a sense of agency that led to an experience that feels more immersive. But where did GOAP come from? Well, it was developed by Jeff Orkin while working on Fear. Now, Fear reviewed well, and most of the reviews that I read mention how smart the enemy AI felt. This article from IGN says, troopers are actually smart. When one spots your flashlight, he'll announce it to the group and everyone will get into formation. If they have you pinned down, expect one guy to keep you engaged while the other breaks away and tries to sneak down the staircase behind you. They'll still jump out into the open and get railed on by your pistol, but the troopers aren't about to just roll over for your amusement. I think all that is pretty cool, but how does it work? Well, it's more like a design pattern or a general solution to a problem than a hard set of rules that you have to program to. So depending on what you're reading, there's at least 5, maybe 8 parts of the framework. We're just gonna go with 5. The 2 sources I used to learn this are listed below. I've just pieced all the pieces together in a way that makes sense to me. There's a lot of circular definitions here, but we'll break them all down. I followed Justin Young's article on how GOAP works. I actually think it'll be easier if you have a visual aid here, so I'm going to try to draw this out. The first part of the system is the agent, or the NPC. And the important thing to know about agents is they have a low IQ. They got smooth brains. And so they need someone to tell them what to do. They need someone to give them direction. And that direction is going to come from our planner. Our planner is the responsible adult here. The planner is going to implement an algorithm that's responsible for generating a plan and giving it to the agent to run. But how does the planner generate this plan? It needs some key pieces of information. The first of which is the goals. Of course, the goals are just the objectives that the agent has, and these goals are going to lead to a desired state. So we'll get into what a desired state is in a second, but an example, if you're making like a first person shooter, a goal might be eliminate player. Another goal might be find cover. The planner also needs to take in a structure of data called state data. State data is really just information about the environment. It's usually stored in key value pairs because it's really easy to read and make decisions based off of key value pairs. And so state data might contain something like player location. If it's known, it'll be set to some vector if you're making a 3D game. It might also know whether the player is alive. We'll set that to true by default, right? And so if a goal is to eliminate a player, the desired world state is going to be player alive equals false, right? And the last piece of information that the planner is going to need is actions. Actions are small units of activity that lead to a goal being met. Some of the stuff that I read said it's very important that these actions of activity don't imply a goal. You want them to be as general as possible. I didn't do that. Maybe that's one of the places where I went wrong. But I guess an example of that is if you've used behavior trees, you've seen there's the built-in move to function or the rotate to function. Like those nodes are general operations that you can pass an objective into, right? And so in GOAP, actions are kind of divided into 3 parts. There's usually a precondition, the action itself, and an effect. And so I guess the ideal way to explain it is the effect mutates what the world state is. And for an action to be taken, a precondition must be true, right? So let's say the action that we're working with is chase player. Well, in order to chase the player, you have to see the player. And let's say the desired effect of chasing the player is you caught the player. So after you've caught the player, what do you want your AI to do? Maybe you want it to kill player. So of course, since actions have to be linked together, one action's precondition is going to be another action's effect. And so the precondition for kill player must be caught player. And the post condition or the effect might be game over or victory or something like that. Sorry, I went off the screen a little bit there. But the important thing to know about these 3 chunks of information is that they're all unique to the agent, right? So these are tied to the agent, and our agent NPC is just gonna request a plan, and the planner is going to run whatever algorithms it needs to run based off of the current set of goals, state data, and actions, and return the plan to the NPC. And then the NPC is going to go off and execute that plan. So aside from these 5 things, you're also going to need a network graph or some sort of graph structure and a pathfinding algorithm. Now, a network graph is a structure that shows some set of objects and how they're related to each other. It probably looks something like this. Let's say we have 5 objects in our graph, and we'll label these 1, 5, 2, 4, and 3. Say 1 is connected to 2 and 5. 2 is connected to 5. 2 is connected to 4. 4 is connected to 5, and 4 is connected to 3, right? So all this does is just show the relationship between objects in a graph. This network graph is going to be used for our actions. What defines a link between 2 actions would be a precondition and an effect. And one of the things that we often do with GOAP is we use weighted graphs, because if you can say to get from 1 to 2 is going to cost you 5 units of blank, but to get from 1 to 5 is only going to cost you 1 unit, you can help influence what decisions make more sense in specific situations. So when you see depictions of a network graph, sometimes you'll see them with numbers defining the cost that it takes to get to each node. So to sum it all up, first, this graph is going to be built from the agent's available actions. Then the agent is going to go request a plan from the planner, and the plan looks at the agent's world state and determines the best goal for it to try to achieve. Then the planner uses the agent's actions to build a plan, and after that, the planner finally returns the plan to the agent, and the agent carries out those actions. That was a lot. I hope you stuck with me for that, but if you learned something from that, please hit the like button. So now that we know what GOAP is, what are the benefits and disadvantages? Now, I do have my own opinions that I'll cover at the end of this video, but for now, I think it's important to focus on what developers with more experience have to say about this, because like I said, I'm just a guy who's studying this on his own. At first glance, I didn't really find too many negatives with this, but then I started digging into some research papers and material like that, and I think that's an important note, because GOAP is probably more of an intermediate or advanced feature to implement. It shines its brightest as well as shows its flaws more when it's scaled up for advanced use cases. Through this research, I found, like a lot of other things we discussed on this channel, GOAP is a tool, and it seems to come down to just using the right tool for the job. So when is it the right tool? Well, if you don't want strict control over your AI, it's going to be great. David Aversa worded it well in their write-up on GOAP versus BTs. He says, in GOAP, we essentially let the AI write its own rules, and in the process, we lose control of the AI. So if you don't have specific events tied to specific moments in your game, and you're okay with NPCs deciding what they do, when they want to do it, however they want to do it, it's going to work well for you. But if you're expecting your NPC's actions to be interrupted, GOAP is going to handle interrupts very, very well. Much better than behavior trees, in my opinion. In this paper, written by Jeff Ortkin himself, he points out that characters in the game can exhibit more varied, complex, and interesting behaviors using GOAP. This makes NPCs feel much more responsive and reactive to the player. On another note, GOAP can also be good for complexity. This article by Chotrani and Jin states that the planner also decouples actions and goals, which heavily reduces complexity compared to other designs. This really matters if you're designing some huge complex behavior system for NPCs. And there's more upsides, but I think you can sum all these up into, if you want your AI to behave in a more realistic manner and you're designing a larger, more complex system, GOAP should work really well for you. But when is it the wrong tool to use? Well, the biggest problem with GOAP is that it's really hard to implement correctly. I agree with that wholeheartedly. If you want specific behaviors to be demonstrated at specific times, getting the planner to do that is difficult because they need so much information to help guide the agent. If the planner isn't implemented correctly, GOAP has diminishing return. Referencing that same paper, it says if GOAP is implemented correctly, you're better off using behavior trees because they'll be more performant. And that's just true. GOAP is more expensive because you're implementing search algorithms, whereas other methods just react to whatever the player is doing. It's also very challenging to make NPCs cooperate with each other while implementing GOAP, because GOAP is very individualistic. This article by Tommy Thompson points out that the fear and AI don't actually work together. They just use dialogue to make it appear as if they are. Even in my example, when zombies form a horde, there's no actual agreement or communication happening between them. One of them just decides to follow the other. Sometimes they decide to follow each other, and nobody goes anywhere. But this may be solvable through something called a reaction synthesis planner. Now that's way above my level of understanding, so I'm going to leave that alone. It's also worth noting that GOAP is a lot of work, and if you're designing something small and simple, the juice may not be worth the squeeze. Depending on what you're doing, you may be able to achieve similar results with state machines, state trees, or behavior trees. I could go on, but every article I've read points to GOAP's effectiveness depending on your use case. If the AI needs to have freedom to perform a lot of possible actions, it's going to serve you well. But for most use cases, simple state trees and behavior trees will be more than enough to achieve your desired behavior. Okay, again, that was a lot. If I missed anything there, please leave a comment and let me know. So real quick, I did implement GOAP, and while it does work, it just had a lot of issues. I chose to do it all in blueprints, and a lot of the pain points came from that because not everything you need to create parts of GOAP, like the network graph, which is usually done in a 2D array, are supported in blueprint. I just had to get a little creative on some parts of it. Now, other issues I had included my inability to not think of more goals for a zombie other than eat, figuring out how to allow actions to have multiple preconditions and effects, and have it make sense in the context of the game. The list goes on, but if you'd like to see a longer video about my implementation and its shortcomings, please just leave a comment. So that's how I ended up here. And to be honest, I can't overstate how good GOAP is. For my short experience with it, it seems to be a near perfect framework where I was only limited by my own creativity and inability to think of more than one goal for a zombie. I guess my takeaways are that it takes a lot of effort up front for a system that feels very robust and scalable. Now that all the groundwork is laid, I think scaling it to support many more enemies of varying types will be relatively simple. Also, adding mechanics to vary zombie behavior, like my desperation mechanic, should be simple enough to add to this implementation. I also want to try giving them a goal to avoid a specific type of enemies, just to give them something extra to do. I also feel like the ideas I had for player actions and abilities feel more meaningful within this system than they did with my previous one. For example, like throwing something to distract patrolling zombies felt very predictable and stale. But with this system, the action will have the same effect, but there's cascading consequences that are possible. Like throwing food may result in a zombie rumble or like an accidental horde forming. Yeah, so I think that's really cool. But I also really like how modular GOAP feels. If there's a part of it that you don't like or a part of it that you need to be more performant, you can just swap it out, right? And here's some things that I think are important to know. GOAP matters a lot based on your use case. This wasn't easy to implement. Like I said earlier, it's probably an intermediate to advanced type of thing, and it will take time to do it. In a standard zombie game like Resident Evil, I don't think GOAP makes a lot of sense for basic enemies because you can get the desired behaviors through simpler means. I also want to note that there's a lot of tutorials out there on how to implement this in blueprints, which I didn't watch. So you should probably do that if you want to, if you want to implement this in blueprints. It's also important to know that it's not a silver bullet. The impact of GOAP is huge, but it's still a part of a larger project. Like, I still have to make sure the characters are balanced and their behaviors make sense in the context of the game. It's totally possible to implement GOAP and still end up with enemies that don't add much to your game or don't feel right in your game. It's not a solution that's going to fix all my design mistakes. And I really want to hear your opinion on this one because I'm uncertain about it, but it seems like small implementations of GOAP, like the one I showed, may not be the best representations of the system as a whole because they mask the issues seen at scale. The inefficiency of my implementation wouldn't matter until there's X number of NPCs at play. I didn't enjoy doing this in blueprints, and I'll probably do it in C++ later because all the major components like the algorithm and the network graph are well documented in C++. So that's my 2 cents. So we started with behavior trees, then we learned a lot about state trees, and now we've implemented GOAP using blueprints and state trees. Doing all that has taught me enemy design is more than what framework I choose and the tools I use to implement that framework. It's finding the right mix of tactics, visuals, behaviors, and balances that create engaging experiences in the game I'm making. And I wouldn't have figured that out without you. So I appreciate y'all. See you next time.